Good morning, class. This is Mr. Eggleston, and this is lesson 2.6, linear reasoning for Algebra 1. And this is the activity. The activity asks how many pretzels? It talks about the Hart family buys their pretzels in a large family-sized tub. When making lunches, Mr. Hart always includes a serving of pretzels. He puts the same number of pretzels in a reasonable bag every time he packs his lunch. Okay? So the table compares the number of lunches made. I'm just reading through this, so we're here. The number of lunches made and the number of pretzels remaining in the tub. So after 3 lunches made, he had 378. After 7 lunches, he had 306, and after 9 lunches, 270, and after 13 lunches, 198. All right, how many pretzels does Mr. Hart put into each lunch, and how do you know? Well, if you look at this, you will see that when we go from, 4, increase the number of lunches made from 3 to 7, it's 4, right? 7 minus 3. And when you do that, you decrease the number of pretzels by 72. All right? When you go from 7 to 9, you increase the number of lunches by 2. And if you look at this, 306 minus 270, that means I don't have the number in front of me. It has Okay, after 2 lunches, you have minus 36. And from 9 to 13, when you increase the number of lunches by 4, you decrease the number of pretzels from 270 to 198. And you decrease it by 72 again. So how many pretzels does Mr. Hart put into each lunch? Well, if he puts the same amount, which is what it says here, puts the same number of pretzels, okay, you can figure out that it would be 72 divided by 4, which should be the same thing as 36 divided by 2, which is 18 pretzels per lunch. And the reason how we know is because after 4 lunches, the number of pretzels decreased. By 72. And that comes from right here. You could also have done this one from 7 to 9, that over those 2 bags of, or 2 lunches, the number of pretzels decreased by 36. After Mr. Hart has made 16 lunches, how many pretzels will be remaining in the tub? Well, we know at 13 lunches, he had 198. So that's 13 lunches. So each time he makes a lunch, he loses 18. So that's 14 lunches. That's 15 lunches. And that's 16 lunches. So it's 198 minus 18 minus 18 minus 18, which is 144 pretzels left. How many pretzels were in the tub to start? Well, to start, He had 378 after 3 lunches made, right? So we would have to add 18 3 times, because after 3 lunches made, you had 378. So for 2, 1, and 0, you have to add 18. And that works out to be 432 pretzels. Okay. How many lunches can Mr. Hart pack with 1 tub of pretzels? Show how you figured it out. Well, with the 198, well, one way, with the 198 pretzels remaining, he can make, well, you got 198 remaining, 198 divided by 18 for each. That works out to be 11 more lunches. So, 1 tub gives, let's see, 198 was after 13, so it'll be 13 plus the 11 more, 24 lunches. Okay. And that's how you can figure it out. There's more ways you could figure it out, but that's the way I did it. Write an equation giving the number of pretzels remaining, P, after making, I guess that's L. I'll make this like that, L. Okay, so P would equal 432. That's the number we begin with, minus 18 times L. All right. So now they want you to graph the equation. So think of this as y equals 432 minus 18x. So, or this is x, but we can also call it L. And this is P or Y. Okay. Now, we begin with 432, which puts us right around there. Okay. And that's 0, 432, because that, when we first begin with no servings, there's 432 pretzels. Then we know that when we have 24 servings, so there'll be 0 left after 24. So we would have a line like that, and that's 24, 0. All right, and that was because of this answer right here. So 1 tub gives 24 lunches, so when you do 24 lunches, there's no more pretzels left. Okay? Now, okay, what do you notice? Okay, I labeled it. Well, the y-intercept, well, be nice if it didn't erase them, or the y-intercept is from question 3, which asked how many pretzels were in the tub to start. Okay. And okay, and it represents how many pretzels are in the tub to start. Okay. The x-intercept is from question 4, and represents when 0 pretzels are left, and represents when the tub is empty. Or 0 pretzels in the tub are left. Okay. Now, let's go back and start kind of hammering home some ideas here. First of all, if we go from 13 to 16 here, 16 lunches made, we've increased the number of lunches by 3, and we would get 144 here, which is minus 4 times 18. All right? And notice, if we want to go in the other direction, if you want to subtract 3 lunches to get to 0 lunches made, you would add, or how would I say this? Well, it would mean this. Minus 3 times 18. So we have to add 3 times 18 to 378 because we would be subtracting 3 times 18. So if you do that, you would end up with having the 432 with the 0 number of lunches made. All right. How many lunches can Mr. Hart pack with 1 tub? Well, the question is, when is P equal to 0? That's what we figured out. All right. And for number 6, graph the equation. Y-intercept, number of pretzels when is the number of pretzels when L equals 0. That means we have no servings, no lunches. And the x-intercept is the number of lunches when P equals 0. Equals 0. Okay. There you go. You might want to write those red things down. By the way, just FYI, I'm not a big fan of pretzels. They just dry my mouth out. Okay. So write the red down. And write the rest. Pause the video, obviously, when you need to. And now we come to the linear reasoning, the quick notes. Here we go. We had 3 learning targets. All right, remember the 3 learning targets? Oh, I didn't show them to you. All right, sorry about that. That's because this does not have the front page. The 3 learning targets are, where can I put them? Right here. LT number 1 was dun dun dun. Was write equations that model linear relationships. Okay. Learning target number 2, I'm going to use a different color just to make it multicolored. Learning target number 2 is solve for missing quantities of a linear relationship. Of a linear relationship. Okay. And learning target number 3 was find x and y intercepts. Of lines using tables graphs and the actual linear equations. Okay. You'll find these learning targets on your student guide. So if you can't read that, or if you want to, see the typed out version, it's going to be on your student guide. I just don't have it in front of me right this second. All right. Now, here are the 3 learning targets, the quick notes. First one is learning target number 1. I'm looking right here. Is to model a linear relationship, identify the starting value b and the rate of change m. Okay, that is y equals b plus mx, which is my preferred form of the equation, or you're probably more familiar with y equals mx plus b. All right. So you want to be able to write equations of this form to model situations. All right. Which we did right here. Learning target number 2, given any point on a linear graph, add or subtract the slope to find other points. Okay. I'm not a big fan of this. So they're saying if we had 2, 10 that we know, and we know the slope, so we can add 1 to x and we add m to 10. Or if we go in the opposite direction, we will subtract m. So it'll make more sense if you just do a few problems, okay? Learning target number 3, y-intercept occurs when x equals 0. That's the easiest thing to figure out is the y-intercept. You just put 0 in for x. The x-intercept occurs when y equals 0. This is a little bit harder to find. Okay. So go ahead, write this down, pause it and copy that down. And then when you get done with that, start working on the check your understanding. Pause this video so you can try the check your understanding, and then you can come back and watch the rest of this to see if you got it right. All right, so I'll pause here for a second and then continue on. So here we go. An ice skating rink charges $4 per hour to skate on the rink. $4 per hour. That kind of gives you a clue that that's the slope. That's the rate. And the option to rent skates for an additional cost. This would be the y-intercept. Marlo paid $13 to rent ice skates and to skate for 2.5 hours. Okay, that means T equals 2.5, or I guess I should say X, because we'll probably use X. And the question is, what is the cost of renting skates? Well, if it's $4 per hour, it will be 4T plus the unknown, well, let me make that X. 4X, because X is T. I don't want to get too crazy. Plus the rental fee will equal the amount money paid. So if he paid, so this is money paid, which is Y. All right. So now, if the amount of money he paid was $13, so I'll make Y 13, and we have 4. Now, X is 2.5, because that's the time you rented for, plus, and we still don't know what the rental fee is, plus B. This is a linear equation that's fairly straightforward to solve. You just have to figure out what 4 times 2.5 is. Well, 4 times 2 is 8, and half of 4 is 2, so that's 10. So we have 13 equals 10. Now, if you don't trust me, type it out on the calculator. I've been doing this enough that I can kind of do some of these in my head, and you get B equals 3. B, that's the rental fee. What is the cost of renting skates? Renting skates cost $3. And that would be the answer. Okay. How much would it cost to rent skates and be on the ice for 4 hours? Well, now we have the full equation. We know we have Y equals 4X plus 3. And for 4 hours means X equals 4. So we can plug, excuse me, we can plug 4 in for X, and you get Y equals 4 times 4. Oops, sorry. Plus 3, which equals, what's it? 4 times 4 is 16, plus 3 is 19. So how much would it cost to rent skates and be on the ice for 4 hours? It would cost, notice I'm answering this in a sentence, it would cost $19. Okay. For the next question, Nico drinks his shakes at a constant rate. After drinking the shake for 3 minutes, there are 14 ounces of shake left in the cup. After 9 minutes, the cup is empty. All right? Graph the relationship between the time in minutes and the ounces of shake left in the cup. Well, they gave you some information here that you'll have to turn into ordered pairs. After 3 minutes, 14 ounces. All right? So 3, 14 is a point on the line. You can plot that. 3, 14 is right there. And then after 9 minutes, the cup is empty. Well, that means there's a point 9, 0, which puts that point right there. Well, that forms a line. Okay, and it says graph the relationship. You can now graph the relationship. We just go boom. And it looks like we're right there. Okay. Writing equation for S, the ounces of shake left in the cup after T minutes. Well, we can find the slope, the rate, from these 2 points. Remember, slope, the rate. M equals, just subtract the 2, 0 minus 14. Change in Y, changing the output over 9 minus 3. That's negative 14 over 6, which is negative 7 over 3. Okay? So S equals negative 7/3 X. And we could figure out, when X is 0, what B must be. Okay? By figuring out that we can find B by knowing that when X is 9, we're going to use this point here. So I'm running out of space, so I'll do it down here. Y equals negative 7/3. X is 9 plus B, and since this point right here is the point 9 comma 0, that equals 0. So multiplying this, you got 9 over 3. 3 goes into 9 3 times. You got negative 21 plus B equals 0. That tells you B equals 21. So we have the equation. All right? The equation is actually S, not Y, is S equals negative 7/3 X plus 21. All right, and that's the answer for B. Identify the X and Y intercepts and explain their meaning in the context of the problem. Well, the Y-intercept is when X is 0. Okay? And if you plug it into this equation here, if X is 0, Y is 21. So the Y-intercept is 21 ounces, which you can kind of see from the graph here because, the Y-intercept's in between 20 and 22. Okay? And the Y, or the X-intercept, is when Y equals 0. Now, that one's a little bit trickier because you're going to have to solve this equation for X. Negative 7/3 X plus 21 equals 0. How do you solve it? Subtract 21. And multiply by 3 if you wish, or multiply by the reciprocal, 3 over negative 7 on both sides, because we're dividing by 7/3. And you get X equal, let's see, 7 goes into 21 3 times, you get X equals 9, which we see from our graph. Okay? So, explain to me in the context. So the Y-intercept is the initial amount of shake. Initial amount of shake. And the X equals 9 is how long it takes to drink the shake. So there you go. All right. And right there, you see, this is what we can do with linear equations. All right. So I hope that made sense. And have a wonderful evening. Bye-bye.